Hey everybody, this is Larry. This is me doing March 3rd, the third day of the March Leetcode Daily Challenge. Double checking. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem, this contest. What am I saying? This poem. I watched Dune 2 last night, so I missed the contest, which in the virtual contest I did very well, so I don't know. It is one of those days. But I like to bring it up because, I don't know, because if you've been on my Discord, you know that I like people celebrating victories, even even smaller ones, because you build up on small victories and eventually you have a pile of big victories, right? That's how I like to think about it. But yeah, I hope everyone's doing okay. I watched Dune 2, Dune Part 2, and unfortunately I was trying to find the bucket and they didn't have the bucket, the popcorn bucket, but the movie was fun. I enjoyed watching it. Let me know in the comments if you watched Dune 2. Please keep it spoiler free, I suppose. I mean, I saw it already, obviously, but yeah. All right, let's get started. Let's take a look at today's poem. We move nth node from the end of list. Okay, so given the head of the length of list, we move the nth node from the end of the list. I think this one I actually do. To be honest, I think these are weird problems, linked list problems. I don't know how much they come up on interviews. I haven't really seen linked list problem that much on interviews, other than least recently used LRU algorithms, because that uses linked lists if you do it that way. But other than that, aside from that, I don't usually see it. I would say that, yeah, if it takes you a while to get this one, especially the cool way. I mean, I know there are a couple of ways you can do it. Can you do it in one pass is a tricky thing. The pass thing doesn't really matter, to be honest. I think if you are able to articulate why, then it's probably fine. What I want to say is that there is a quote-unquote cool way of doing this problem, and I'm going to do it that way, and I'll show you how to do it. But also, to be honest, like I don't think I don't remember. You could maybe check my videos, because I probably have it on video the first time I did it. I probably didn't do it that intelligently the first time. It probably took me a while if I did. I think these are just, like, for me at this point, I probably solved it like 3-4 times, maybe. I don't know, a variation of this problem 3-4 times, or maybe even more. Just like recently on Leetcode, I've solved it 3-4 times, and so like that's how I get the answer. But I don't know, it's so like random, and I don't even know if it really helps that much. It is kind of cool, and it's a fun idea to see for the first time, but don't beat yourself over if you haven't. I would also say the thing about one pass, and maybe I've said it in the past because I make the same rant a lot. The one pass thing doesn't. The thing about having things in one pass, at least back in the day when there are two major constraints. One is memory. Just in general, I mean, I know that there are many levels of cache, and now there's even like predictions and stuff like that. I'm not gonna get into that deeply. If you're interested in system architecture, I definitely recommend reading on cache. But back in the day, and when I say back in the day, I mean maybe like 20, 30 years ago. And this is even before my time, perhaps, because I mean you need to be mindful of it. But nowadays, you just have so much memory that usually you don't, or it's not like the first few things that you do, right? Like it would be a premature optimization to optimize for memory if you have enough memory, because memory is very cheap. In general, and abundance, unless you're doing something crazy. And in that case, you probably get more out of like parallelizing and stuff like that, right? Which is where big data comes from and all these things. Not gonna get into it that much, but if you do find these kind of rant interesting, let me know in the comments, because sometimes I feel like I talk a lot about random things, and I don't know if people find it interesting or even useful or whatever. But yeah, but the one pass thing, like I said, is a relic of the past where memory is just much more expensive, and the reason why you want to do it in one pass is because it just costs so much to jump from one chunk of memory to another chunk of memory and so forth. And in using arrays and stuff like that, it's not even about having it seeking from memory, but it's about cache usage, because you have this thing about cache locality, and just like you could retrieve chunk of memory at a time and then into cache, and you have on the lower level cache, maybe it's like 8 numbers or 16 numbers, whatever it is back in the day, depending on the architecture and all these random things. Then you could kind of read that really, really fast, right? Because it's on a low level cache and the multi-layer cache. However, on linked list, a lot of this, of course, depends on how the memory is allocated. And the point of a linked list, in fact, is that the memory location should be independent of each other. I mean, obviously, if you allocate things like at roughly the same time, there is a lot of memory locality, but as you kind of manipulate linked lists, and that's the point of a linked list, is you can remove and add nodes in time, the memory is going to get like pretty much jump on. You're jumping all over the place, right? And in that sense, doing it one pass or two pass, I mean, or three pass or whatever it is, is it that much? Is it important? I don't know. I mean, I guess you still get some benefits of one pass, but you know, if you do it in one pass, but you use 2 pointers where the memories are like jumping all over the place, finding each other, which we will do, to be honest. Spoiler alert. Do you have any? Is there much? Like, is there any memory improvement? And the memory improvement allows us, you know, ultimately allow the code to run faster, more efficient, and that's the idea, right? But it's a long way of saying that one pass thing doesn't really matter because it just doesn't really lead to speed advantage. I mean, I guess there probably is slight speed advantages but is it actually? I don't know. I don't believe so, to be honest. Or like, you know, it's a rounding error or something like this. So yeah. Anyway, so that's a long rant. Let's get to it. Let's get to solving this problem. So the idea here from nth node from the list, right? How do you get the nth node from the list? So the one hint that you may get, or I may give you, is that use 2 pointers, right? If you're stuck trying to think about using 1 pointer, I don't know that is possible, at least in one pass. But if you use 2 pointers, then it becomes, you know, now you can think about other things, right? Now your domain expands and there are just more strategies and stuff like that. And here, nth node from the n, what does that mean, right? So your naive approach, your first approach may be like, okay, well, you count all the nodes and then you subtract n from the number of nodes, right? But here now, if you have 2 pointers, then you could do it at the same time. You could have one that is n lagging behind. Then if you go in lockstep, then the second node would be n from the end of the list, and that's the answer. Yeah. Oh, I said about all those interview stuff, and then like, you know, I see that there's this thing, so I don't know. Maybe people do ask this, but I haven't seen it in a while. I don't know, could be wrong. Oh, and they give you n. Oh no, n is the nth node from the list. Okay, not like total n. Alright, so yeah. So I always like to have sentinel heads. So let's do it that way. But I think these things, for me, to be honest, I always worry about off by 1. So I don't know. 1 head. So you have to be careful. I'm like really thirsty right now. Just to also, I don't know who is watching this, but yeah, I'm really thirsty right now. I'm how long am I? I'm about 40 hours into a dry fast, so I don't know. But I'm okay. I'm monitoring everything, just to be clear, because I think there are some concerns about safety and health and all these things. But it's not the first time, so it's fine. And at worst, I just drink water. It's not that. Okay, so then now we want to go ahead n step so that the front is n ahead of the back, right? Okay, and then now new front head is n instead of new heads. Then now we go new front head dot next is not none. Oops. I don't know why okay, fine. It's too late. I called them new. Maybe new is such a weird way of putting it. Maybe they should give it like front pointers and back pointers. Yeah, well. Yeah. And then that's pretty much it. And then we just, yeah, return new. I could be off by 1 just because it's so easy to be off by 1, but I think it's next dot head though. Oh, you have to return the node. Okay. I think this is dot next though, because we always care about the dot next part, the way that we structure it. Oh, wait, what? Oh. Oh, we have to remove this node. Okay, I thought we just returned the node. No, it's fine. Wait, I mean, now that we find the node, but this is why we keep the dot next, because then now it's very easy, right? Because now we just do dot next is equal to new back head dot next, but we have to also call original head is equal to something like this, and then now we can return original head dot next, right? Right? Dong. Am I off by one? I'm probably off by one, but is that really the expected though? Oh, from the end, I guess so. Why do I get this off by one? Alright. So n is equal to 1. So this loops once. Right? This is already none, so then this should already be the head. New back head dot next should be right. Oh, I see. I see. Okay, fine. I get it. It's just that I'm being a little bit silly because this. Okay, fine. The reason why is because this original head is not the same as, like, we manipulated the pointer of this because this is the head. Okay, fine. Right. So I don't really handle removing the first node correctly because of the way I wrote this. This is wow. It's very easy to mess up. But yeah, not that bad to fix, but kind of have to be careful about this one because we want them to have the same pointers. That's basically why for removing. How did I handle that in the past? I guess I just, oh, I see. Because I just make sure that they all reference the same one. I kind of wrote it a little bit funky by creating a new pointer, and to be honest, I didn't think about that much. Or clearly, I didn't think that much about creating a new pointer, but they should all reference the same pointers, and I think that's a cleaner way of doing it. So the way that I did it last time is probably the cleaner way. Definitely, I mean, the same idea, but actually, pretty much everything's the same except for the variable names and this thing. So definitely have to be careful, and I kind of did it backwards, so it's a little bit funky. But yeah, that's all I have for this one. This is going to be linear time, constant space. You know, you have to go through the list. This is one pass, even though there's a for loop because we only, you know, this only goes through one pass, this only goes through one pass, I suppose. I don't know, one pass is kind of an awkward thing to say, like I said, for linked lists and multiple pointers, so I don't know. Anyway, that's all I have for this one. Let me know what you think. And yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.